Welcome to the Beginner C# programming tutorial. This video will introduce you to the Unity C# script, describe why we need them, and then explain a C# script's default structure. Now, in our games, all the game objects perform some tasks or exhibit some behavior. For example, you want your game character to walk or jump, the enemy to attack, or the gun to shoot. Now, if you create a 2D or 3D character and then put it in your game, it will not automatically walk, jump, run, or perform anything by default. Let's say if you press space, you want the character to jump. So somehow you also need to add this instruction to your game character so that it understands this command. To do that, we write our codes inside a Unity script and then attach them to the game objects so that it can perform any task or exhibit specific behavior. So whenever we want to add specific behaviors, we have to create Unity scripts for those particular behaviors and then attach them to the game object. Now I'm going to create a C# script in Unity. Now all the C# scripts needs to be attached to a game object. So we are going to attach it to the main camera game object here. Now the first thing I'm going to explain is called namespaces. And I'm going to show you the example. Okay. So this section here, using system.collections, using system.collections.generate, using Unity Engine, these are examples of namespaces. A namespace is simply a collection of classes, and I'll explain class in a minute. Now, most programming languages, including C#, has some built-in libraries of classes ready to use for us. These classes are then organized under different namespaces based on their functionality. For example, many classes or methods we'll be using in the future are already under this Unity Engine namespace. So we do not have to create or define these classes or methods again to use them in our codes. If we want to access all classes or functions of a particular namespace, all you need to do is type using and then write the namespace's name. For example, there is a life bar or some section in most games that shows the main characters or enemies' health. In some games, there are also dialogues on the screen. These features are part of the user interface, and they are under a different namespace than Unity Engine. So if you want to get access to that namespace to use these features I have just mentioned, within your script, you have to type using, then a space, Unity Engine dot UI. And it has to be at the top of your script. So it has to be before your class starts. Now you will be able to use the classes or methods under the Unity Engine.UI namespace. Now, most of the classes or methods specific to Unity are inside this Unity Engine namespace. For this reason, you'll notice this namespace at the top of most of your scripts. So what happens if we remove it from a script? Let's remove it now and see what happens. Okay, as you can see, instantly this red zigzag line appears under the word monoBehavior. This is because monoBehavior is a programming class that is defined in the Unity Engine namespace. So when we revoke the Unity Engine namespace's permission, our script becomes confused as it no longer recognizes or understands this monoBehavior class. So let's get it back because it is a very important namespace for us and we need it to use the features of monoBehavior class. Okay, so when we create a new C# script, Unity by default gives the script access to these top 3 namespaces because Unity assumes that we'll be using classes or methods from these namespaces in our script. Now, notice the color of these 3 namespaces: system.collections, system.collections.generate, and Unity Engine.UI. The color of these 3 namespaces is a bit it's a bit faded than the Unity Engine namespace. And the reason is we haven't used any classes or methods from these 3 namespaces yet. But the color of the Unity engine namespace is a bit darker as our script is already using some classes from the namespace. For example, this monoBehavior class. We don't need these two namespaces, system.collections and system.collections.generic, all the time. But I recommend leaving them as they are because they are not hurting anyone here. So just leave them as they are. Okay, so I hope you understood the concept of namespaces. Now let me explain this line here. Public class new behavior script colon monoBehavior. This word public means other scripts than the script we are currently working on will have or can access this class. If it are private, then other scripts cannot access the contents of this class. This class is the building block in an object-oriented programming language like C#. I'll explain class in detail in a later video when it will be more appropriate and you have more understanding of C# language. So let's leave it for now. This new behavior script is the name of the class. It is also the name of the script. The class name and the script name must be identical. Otherwise our script will not work. This colon here means inheritance. In simple terms, this means our new behavior script class is inheriting all the features of monoBehavior class. And we already know monoBehavior is a programming class under the Unity engine namespace. I'm going to make an example so that you understand the basic idea behind inheritance. Now, let's think about what features are standard in all cars. Let's write them down. Okay. Cars usually have 4 wheels and cars have headlights. Let's stop at these two features. Now, let's say there are two car companies, Ford and Ferrari. Now, if we say Ferrari inheriting car, this colon means Ferrari inherits all features which are defined under the class named car. So any Ferrari car can have the features of a typical example of a car, which is having 4 wheels and headlights. The same logic goes if we say the opposite as in like Ford inherits car. But it doesn't say anything about color or other unique features, so while Ford or Ferrari is inheriting all the essential elements of a car, they can also add their respective car models' unique characteristics. We are basically doing the same thing in our script. We are inheriting from monoBehavior, and then we also write some of our own codes in the class's body. The body of the class is from this curly bracket to this curly bracket. So anything we write between these two curly brackets is a part of this new behavior script class. Anything written outside of this curly bracket is not a part of the class. For example, if we write something, let's just say now this line here, it is not a part of the new behavior script class because this was written after this curly bracket here. Let me show you. So basically this space here, anything we write in this space will be a part of the new behavior script class because this space is between this curly bracket and this curly bracket. Okay, I hope you understood the concept. Anyway, we'll be covering them in detail in future lessons, so don't worry much if you didn't understand it completely. Now let's delete everything and tidy up our script. Okay, so this green line here and here, these are called comments. I'll describe comments in the next video in detail, so let's leave it for now. Now let's open a link to understand the next concept. I have already had it open on my browser. So if you follow this link, or search for order of execution for event functions, you should be able to land on this page. Okay. So this void start and void update, these are called event functions. These functions are known as event functions since Unity Engine activates them in response to events that occur during gameplay. For example, the start function is called before the first frame update, and the update function is called once per frame. Now, there are other event functions, and from this image, you can see all the event functions, and you can also see the order in which they get executed. As you can see, the first event function is awake, and here is our start function, and somewhere down here is our update function. So let's create the add function after the update function on our script to check if it really follows the order shown in this image or not. Now type everything exactly the same way I'm typing on the screen. I'll explain a debug.log command in the very next lesson, so don't worry if you do not understand it now. We know codes in a program usually executes from top to bottom, so it should be printed in the order we have typed in our script. So it should be 1, then 2, then 3. Now let's go back to Unity and check if that is really the case. But we can see that 3 was printed first on the console. This command was under the awake event function. So even though the awake event function is under both start and the update function, it was executed first, not last. It doesn't matter where the awake function is within our code or script, it will always get executed first. Now notice another thing, you can also see 2 has a massive number beside it in the console, and the number is still increasing. The reason behind it is this command is under the update function, and the update function is called once per frame. So it is being executed continuously, while the other 2 commands are performed only once in their respective order of execution. Okay, so I hope you learned something about event functions. I know these concepts are confusing and not easy to describe in simple terms, but I guarantee you as we progress, these concepts will become crystal clear as I'll be explaining them again and again in later lessons. So don't worry about it much now. We have just started. So I'll see you in the next lesson.